In Part 5 of the Unit 1 notes, we are going to be covering operations with scientific notation. These can easily be done without the use of a calculator, and while it sounds complicated, it's actually kind of easy. First, we will start with addition and subtraction of scientific notation. In order to add or subtract a number written in scientific notation, the exponents must be the same. If the exponents are the same, you can simply add the coefficients and carry the exponent through to the end. So here you can see 7.35 times 10 to the second and 2.43 times 10 to the second. Since the exponents are the same, I'm just going to add up these numbers, so 7.35 and 2.43. That adds up to 9.78. The exponent just carries through, so we don't have to do any math with that part. If the exponents are not the same, you can change the exponent so that they are the same as the largest exponent by simply sliding the decimal. This is similar to what we did in the previous lesson. So if I had 3.7 times 10 to the 5th kilograms, and I wanted to add that to 2.5 times 10 to the 6th kilograms, I want to change this exponent until it matches this one, until it's a 6. Now if I need to make this exponent larger, remember the concept of balance, I need to make this coefficient smaller. So I'm going to slide this decimal one spot to the left. That makes this value now 0.37 times 10 to the 6th kilograms. Now, while this is not proper scientific notation, it's just something we're going to use temporarily so that we can add our numbers. So now I'm going to take my 0.37 and add it to 2.5. We end up with 2.87 times 10 to the 6th power. Now that the exponents are the same, they can just carry through. The rounding for this is going to be related to significant figures, which I also mentioned in a previous lesson. We're not going to worry about that today. If you were to change the exponents so that they were the same as the smallest exponent, you would need to convert the final answer into proper notation. So it would still work, you would just have an extra step to do. So you might end up with something like 28.7 times 10 to the 5th power. Then by sliding your decimal over, you would end up with the same exact answer that we had above. So you can still do it that way, it's just going to take you a little bit longer. All right, next up, we are going to be going through some problems without the use of a calculator. So I have 6 times 10 to the 4th and 4.1 times 10 to the 5th. The first thing I want to do is make both exponents of 5, because that's the larger exponent. I can do that by sliding this decimal one spot to the left. So I'm going to change that to 0.6 times 10 to the 5th. Now that I've done that, I can add the 0.6 and the 4.1. So that is going to be 4.7, and the exponent is just going to carry through. All right, for our next one, we have -4 and -5. Out of these two, the larger exponent is actually the -4. So don't let that 5 confuse you. Remember, it's further down the number line. So I want to change this to a -4. To do that, I'm going to slide this decimal one spot to the left. So it's going to become 0.5 times 10 to the -4th power. Once I do my subtraction, I'm going to end up with 6.7, and then the times 10 to the -4th is going to carry through. All right, for number 3, between a 2 and a 3, the 3 is larger, so let's change this exponent. And slide over one spot to the left again. Now that my exponents match, I can simply add these together, and I have 1.33 times 10 to the 3rd. For our final problem, between a 9 and an 8, a 9 is larger, so we're going to slide this one spot to the left, 0.41 times 10 to the 9th. Now I can subtract. Your answer would be 5.29 times 10 to the 9th. All right, next, we are going to be covering multiplication and division of scientific notation. Multiplying and dividing numbers in scientific notation is a three-step process, but it does not require that the exponents are the same. So we're not going to have to slide over our decimals and change our exponents in the beginning like we did before. Your first step is to multiply or divide the coefficients and the units of the problem. Then, if you multiplied, you're going to add the exponents, and if you divided, you're going to subtract the exponents. Finally, you're going to change your answer to proper scientific notation if it is necessary. So in our example here, we have 9 times 2, which is 18. Since this is multiplication, we add our exponents. So 8 plus 2 is 10. Then we need to slide our decimal over one spot to the left, which is going to increase our exponent to the 11th power. I actually have a minor error here. This should not be kilograms. If we have meters times meters, this should be meters squared. All right, for our next set of checkpoint questions, we are going to be multiplying or dividing each of these. So we have 2 times 6, which is going to be 12. Then we're going to add our exponents, so an 8 and a -5 is going to be a 3. And then we need to slide that decimal one spot to the left. So we have 1.2 times 10 to the 4th power. All right, for our next one, we have 4.5 times 2, which is 9, times 10. We're going to add our exponents, so a 6 and a 2 is 8. All right, for number 3, we have 6 divided by 1.5. So that's going to come out to 4. Since we're dividing this time, we need to subtract our exponents instead of adding them. So I have 5 minus 3, which is 2. Our next problem is also division. 6 divided by 3 is 2. And we're going to subtract our exponents. We have 10 minus 12, so -2. Finally, we have 7 divided by 2, that's 3.5. And then -3 minus a -4. So we have those double negatives there. So that's actually going to come out to a +1. Now for most of these, we did not have to slide the decimal in the end, but you can see that we did have to do that for the first one. So it is something that you're going to have to look out for based on whatever your answer is for the coefficient. That concludes part 5 of the Unit 1 notes. When we come back in part 6, we're finally going to get to counting significant figures.